I guess in the spirit of this entire day, now for something completely different. Most of my work for the past 20 years has been on understanding industrial productivity and performance generally, and then in sort of the spirit of the literature on the energy efficiency gap, thinking about the energy efficiency in industry in the context of distributions. So there's a range of performance, not just sort of a best practice and an average practice, but there's a whole distribution. And the thing about industry, and the reason that I was drawn to it, is that there's so much diversity already in that, quote, sector of the economy, and it's, in the US, it's a third of the energy use. And so there's a lot of diversity across the sector, different types of industries. But even when you look at narrowly defined industries, the buzzword in economics is unobservable heterogeneity. But when you talk to business people and policy people, it just comes down to all plants are not the same. So this is a picture from a study where we looked at energy-intensive, trade-exposed sectors. These are 6-digit NAICS codes. So they're things like the cement industry or container glass industry or paperboard. So they're already fairly narrowly defined industrial sectors, but yet these are distributions of the energy cost shares normalized to it's almost impossible to read, but that's 1. So we normalize it to the mean, and you can see that the gist here is that the distributions within these sort of narrowly defined industries is oftentimes quite broad, and the shapes of them are all completely different. So this is just sort of raw data. It comes from work using the confidential data that the Census Bureau collects. One of the reasons I'm here at Duke now is that we have one of these census data centers, which I'm a director of. And so I've been trying to make use of that data to get more information about plants. And in particular, some work that I've been doing now for about 10 years with Energy Star is to take one of these sectors and say, well, this is just sort of the raw distribution, but there are things that we can measure about plants that explain some of the differences in energy use. And they might be product mix, they might be vertical integration, they might be even things like weather. And in the end, what I do for Energy Star is we come up with this thing which we call a industrial plant energy performance indicator, because a statistically adjusted productivity distribution doesn't come trippingly off the tongue, particularly since we want people in industry to use this. So, this is a slide that EPA likes to use. It's basically sort of appealing to the labeling notion. You might be in an industry, you might know which is your best plant, but you don't know if your best plant is only average unless you have some idea of where you are in that distribution. And so, in the case of the auto industry, which is one of the first industries we did this for, we were looking at the energy use per vehicle, controlling for things like the size of the vehicle. So, as it turns out, we know the answer to this question, but in terms of the answer to this question, 10 million BTUs per vehicle is actually quite hot, would be a rather high number compared to the industry. But we had to go into the data and be able to draw out that distribution, and then also do things like, why does the size of the car matter in terms of the energy use? The engineering reason for that is that 70% of the energy use in an auto assembly plant is painting the car. So the mix of the vehicle mix, the types of vehicles that are being made matter. And there are issues that emerge in every one of these industries that are unique. We've done about 20 case studies now for EPA. They are using these tools to provide public recognition for companies. So if a company finds that they are in the upper quartile of the normalized distribution, then they can apply to EPA and become an Energy Star certified plant. And I should have had a slide up here that shows a cement plant flying that little blue Energy Star flag, because they're out there, pharmaceutical plants, auto plants, that have shown that they're in the upper quartile of performance. So they get a little bit of recognition, and EPA thinks that this also helps them boost their energy management program. We've been looking also at how these distributions change over time. The story is different for every industry we look at, but how that moves, whether it's low-performing plants that are sort of going away or improving, or the whole industry sort of moving along together in terms of their change. That informs what's sort of happening. But we've done other industries, and every time you do one, you get a different picture. Going forward, some of the research that I'm interested in doing, continuing to use this census confidential data, is to look more at changes over time, to look at other measures of environmental performance, and how it relates to productivity generally in an industry and not efficiency specifically. And I kept us on time. How about that?